Imagine investing millions of dollars, countless hours, and endless effort into an ambitious construction project, only to watch it fail in the most spectacular way imaginable. From crumbling towers to failing structures, disasters like these remind us how even the grandest of designs can face catastrophic challenges. Towering skyscrapers, massive bridges, and even the collapse of the world's third-largest suspension bridge reveal how monumental efforts can falter due to engineering errors, overlooked details, or sheer bad luck. In this video, we're exploring some of history's biggest construction blunders. These cautionary tales showcase how ambition can turn into disaster, proving that no project, no matter how impressive, is immune to failure. Buckle up for a jaw-dropping journey through the world of colossal construction failures. The Leaning Tower of Pisa. The Leaning Tower of Pisa is arguably one of history's most famous architectural mistakes, yet its iconic tilt has turned it into a global marvel. At first glance, it might seem like a brilliantly crafted masterpiece, but the tower's most distinctive feature, the lean, was never part of the plan. Construction began in 1173 with the aim of creating a freestanding bell tower for the nearby Pisa Cathedral. However, trouble emerged early in the process, specifically by the time workers reached the third floor. The soil beneath the structure proved unstable, and the tower started tilting. With a foundation just 3 meters deep, the ground could not support the tower's immense weight, causing it to lean even before construction was halfway complete. Political unrest and wars forced construction to halt for nearly a century, a pause that ironically saved the tower. During this time, the soil had a chance to settle, preventing an immediate collapse. Yet, as construction resumed and the tower was completed in 1372, the lean became more pronounced, cementing its unusual character. Over the centuries, the tilt worsened, prompting numerous restoration efforts to preserve the structure. The most significant intervention began in 1993 and lasted until 2001. Engineers employed innovative techniques to reduce the tilt and stabilize the tower, ensuring its survival for future generations. Today, the Leaning Tower of Pisa stands not only as a testament to medieval engineering challenges, but also as a symbol of resilience and ingenuity. The Lotus Riverside Complex. In 2009, the collapse of a building in the Lotus Riverside complex in Shanghai became one of the most dramatic construction failures in modern history. This residential development, intended to symbolize Shanghai's urban progress with sleek high-rise apartments, instead became a cautionary tale of engineering missteps. On June 27, 2009, one of the buildings unexpectedly toppled over like a massive domino. Unlike other collapses often attributed to natural disasters, this failure resulted solely from human error and poor construction practices. The primary culprit was a serious flaw in the building's foundation. The issue began during excavation work for an underground garage beneath the building. Large amounts of soil were removed from the area, weakening the already unstable ground beneath the structure. Heavy rains shortly before the collapse further destabilized the soil, leaving the foundation unable to support the building's weight. Finally, the combined stress caused the structure to slowly tip over onto its side. What made this incident even more startling was that the building didn't crumble upon falling. It remained largely intact despite being severely damaged. The dramatic image of the fallen building quickly spread worldwide, drawing attention to the risks of rapid urban development, especially in booming cities like Shanghai. The Lotus Riverside collapse highlighted the dangers of inadequate foundation design and improper excavation techniques in the rush to meet the demands of growing urban populations. It serves as a stark reminder of the catastrophic consequences that can result from cutting corners in construction. The Hyatt Regency Walkway Collapse. The Hyatt Regency Walkway collapse in 1981 stands as one of the deadliest building failures in U.S. history. Located in Kansas City, Missouri, the hotel featured a stunning atrium with suspended walkways connecting the second and fourth floors, a hallmark of its architectural elegance. However, this symbol of beauty turned into a scene of tragedy on July 17, 1981. During a lively Friday night dance event, as hundreds of guests gathered in the atrium, disaster struck. Without warning, the two suspended walkways gave way, sending dozens of people crashing to the ground below. The catastrophic failure resulted in 114 deaths and over 200 injuries, many of them severe. The nation was left shocked, and the incident prompted intense scrutiny of construction practices and safety standards. The collapse was ultimately traced to a critical design change made during construction. The original plan called for a single set of hanger rods to suspend both walkways from the ceiling. However, the design was altered to use two separate sets of rods, one for the second-floor walkway and another for the fourth. This change inadvertently doubled the load on the connection points where the rods attached to the walkways. The connection points, not designed to handle the increased load, failed under the weight. This structural oversight led to the devastating collapse, forever changing the landscape of engineering safety protocols and serving as a grim reminder of the importance of adhering to original design specifications. The Aquadom Aquarium burst. The Aquadom in Berlin, once celebrated as the world's largest cylindrical aquarium, was a breathtaking feat of engineering and a prominent tourist attraction. Standing an impressive 82 feet tall, the massive acrylic tank housed 1,500 tropical fish and was located inside the Radisson Blu Hotel. Visitors marveled at its unique design, including an elevator that passed through the center, offering an immersive underwater experience. The Aquadom symbolized Berlin's innovative architecture and was a beloved landmark for both tourists and locals. However, in December 2022, disaster struck when the Aquadom suddenly burst, unleashing millions of liters of water. The flood devastated the hotel lobby, surrounding streets, and nearby infrastructure, causing significant damage. Tragically, hundreds of tropical fish perished, and the event led to millions of dollars in losses. Unlike collapses caused by external forces such as earthquakes, the Aquadom's failure stemmed from a structural flaw in its acrylic walls. Over time, microfractures, tiny cracks invisible to the naked eye, formed in the acrylic material. These flaws were exacerbated by environmental factors such as temperature fluctuations and the immense pressure from the water inside the tank. As the microfractures worsened, the structural integrity of the tank deteriorated until it finally gave way. The sudden collapse of the Aquadom raised concerns about the durability and long-term safety of large-scale structures made from materials like acrylic. While it had been an awe-inspiring architectural and engineering achievement, the incident highlighted the potential risks associated with complex installations subjected to constant pressure and environmental stresses over time. The Aquadom disaster serves as a sobering reminder of the challenges in maintaining such ambitious structures. The sinking of the Vasa. Sweden's King Gustavus Adolphus commissioned the construction of the Vasa, a grand warship intended to showcase the power and dominance of the Swedish Navy. With its majestic design and formidable array of cannons, the Vasa was meant to be one of the most impressive warships of its time. However, its maiden voyage turned into one of history's most infamous maritime disasters. On August 10, 1628, the Vasa set sail from Stockholm's harbour. Yet, within just 1,300 meters of leaving port, disaster struck. The ship began leaning uncontrollably to one side and quickly capsized, sinking into the harbour's waters. Despite its imposing size and firepower, the Vasa was tragically unstable, a consequence of a critical design flaw. The ship was top-heavy, with too much weight concentrated in the upper decks and insufficient ballast in its lower sections to counteract the imbalance. This instability, combined with a sudden gust of wind, caused the Vasa to tilt beyond its tipping point. Tragically, dozens of crew members aboard the ship perished as it sank within minutes. The disaster highlighted the dangers of prioritizing grandeur and firepower over fundamental engineering principles like weight distribution and stability. The Vasa's excessive height and lack of proper ballast made it inherently prone to tipping over, a flaw that was ignored during its construction in favor of the king's ambitious demands. For over 300 years, the wreck of the Vasa lay at the bottom of Stockholm's harbour. In 1961, the ship was finally salvaged and meticulously preserved. Today, the Vasa is housed in a dedicated museum and serves as a stark reminder of the consequences of neglecting essential design principles. While it stands as a marvel of historical preservation, it also symbolizes the catastrophic cost of ambition unbalanced by careful engineering. The Teton Dam Disaster. The Teton Dam in Idaho, completed in the 1970s, was an ambitious project designed to control flooding, provide irrigation, and supply water to the region. Built using compacted layers of soil and rock, it was considered a cutting-edge piece of infrastructure at the time. However, on June 5, 1976, the dam suffered a catastrophic failure, resulting in one of the most devastating engineering disasters in US history. The trouble began as the dam's reservoir reached full capacity for the first time. Initially, small leaks appeared in the dam's structure, which were thought to be manageable. Efforts were made to seal them, but the situation rapidly deteriorated. Within hours, the dam suffered a massive breach, unleashing over 250,000 acre-feet of water downstream. The resulting flood devastated the towns of Wilford and Rexburg, destroying homes, businesses, and infrastructure. Tragically, 11 lives were lost, and the financial cost of the disaster was estimated in the billions. Farmland, livestock, and the natural environment were severely impacted, adding to the scale of the catastrophe. The root cause of the Teton Dam's failure lay in poor construction techniques and the use of highly porous rock in its structure. This porous material allowed water to seep through, progressively weakening the dam from within. As leaks worsened, the infiltration of water further destabilized the structure, ultimately leading to its collapse. Despite being considered advanced for its time, the dam's design, materials, and insufficient oversight proved to be its undoing. The Teton Dam disaster stands as a stark reminder of the importance of rigorous engineering, proper material selection, and comprehensive oversight in large-scale infrastructure projects. The Sampoong department store collapse. The Sampoong department store in Seoul, South Korea, once stood as a symbol of the country's rapid economic growth during the 1990s. Built in 1987, the structure was initially designed as a 4-story office block. However, during construction, plans were altered to transform it into a 5-story luxury department store. This seemingly minor decision had catastrophic consequences. To accommodate the new design, several critical support columns were removed, significantly weakening the building's structural integrity. Additionally, a heavy air conditioning unit was installed on the roof, adding a substantial load that the foundation was not designed to bear. These changes undermined the building's ability to safely support its weight. Long before the disaster, the building exhibited clear warning signs. Cracks appeared in the walls and floors, signaling that the structure was under severe stress. Despite these warnings, the building's owners and management chose to ignore the problems, failing to take corrective action. This negligence proved fatal. On June 29, 1995, the Sampoong department store collapsed, resulting in the deaths of 502 people and injuring nearly 1,000 others. The tragedy stands as one of the deadliest building collapses in modern history. Investigations revealed that the disaster stemmed from a combination of poor safety standards, disregard for engineering principles, and greed-driven decisions. The structural modifications, coupled with a failure to address clear warning signs, highlighted the deadly risks of cutting corners and ignoring proper construction protocols. The Sampoong department store collapse serves as a stark reminder of the critical importance of adhering to safety regulations and prioritizing structural integrity over short-term gains. It stands as a cautionary tale about the devastating consequences of negligence and poor oversight in construction. The Walkie-Talkie Building. In 2014, London's Walkie-Talkie Building, officially known as 20 Fenchurch Street, made headlines not for its striking architecture, but for an unintended and hazardous consequence of its design. The building's distinctive concave glass facade, intended to be an architectural statement, instead turned it into a giant mirror capable of focusing sunlight into intense, concentrated beams of heat. This design flaw caused the building to earn the nickname "Skyscraper" after it was discovered that the concentrated sunlight was powerful enough to melt parts of a Jaguar car parked below. The heat also scorched nearby buildings, damaged street signs, and warped pavement, with temperatures on the street reportedly reaching a staggering 243 degrees Fahrenheit, 117 degrees Celsius, far beyond typical London summer heat. The intense glare made it nearly unbearable for pedestrians to walk near the affected areas, leading to public outcry. To address the issue, emergency measures were taken by the building's architects and developers, who installed sunshades to deflect the sunlight and mitigate the problem. While the Walkie-Talkie Building's design was visually striking and undoubtedly unique, the unforeseen heat hazard underscored the importance of considering environmental and engineering impacts in architectural projects. This incident serves as a cautionary tale about the potential consequences of prioritizing aesthetics over practical design considerations, showing how daring architectural statements can backfire when critical details are overlooked. The collapse of the Tacoma Narrows Bridge. The collapse of the Tacoma Narrows Bridge, affectionately known as Galloping Gertie, on November 7, 1940, remains one of the most infamous engineering failures in history. Designed by engineer Leon Moisseiff, the bridge incorporated the latest advancements in suspension bridge theory, boasting a sleek and modern design intended to save costs while providing an efficient route for motorists. However, just 4 months after its opening, disaster struck. On that fateful day, winds of just 40 miles per hour caused the bridge to twist violently, with the deck moving like a ribbon in the wind. This unexpected behavior created dangerous instability that the bridge could not withstand. The cause of the collapse was traced to a critical flaw in the design. The bridge was too aerodynamic. While the lightweight structure and innovative design were seen as groundbreaking at the time, they failed to account for aerodynamic instability. The bridge lacked proper damping systems to counteract wind forces, which led to uncontrollable oscillations. These relentless movements eventually caused the bridge to collapse into the cold waters of Puget Sound. While tragic, the collapse of the Tacoma Narrows Bridge served as a pivotal moment in bridge engineering. Investigations revealed that the lack of damping systems and the bridge's unique aerodynamic properties had created the conditions for the disaster. The lessons learned from this event had a profound impact on future suspension bridge designs, leading to the incorporation of better wind resistance measures and more robust structural elements. The collapse of Galloping Gertie underscored the need for a deeper understanding of aerodynamics in bridge design, highlighting the critical importance of ensuring structural stability under all environmental conditions. The Aon Center Marble Crisis. The Aon Center in Chicago, originally known as the Standard Oil Building, serves as a striking example of how the choice of luxurious materials can sometimes lead to disastrous results in architecture. Completed in 1973, the building was designed to stand out with its sleek, modern appearance, and its exterior was clad in Italian Carrara marble, a material renowned for its beauty and elegance. However, within just 1 year of its completion, the marble began to show signs of severe distress. Cracks appeared across the facade, and in some cases, entire panels of marble weighing over 300 pounds detached and fell to the ground below, posing a significant risk to pedestrians. The culprit behind the marble's failure was Chicago's extreme climate. The city experiences drastic temperature changes, with hot summers and frigid winters. These fluctuations caused the marble to expand and contract, putting immense pressure on the material. Over time, this constant shifting weakened the marble, leading to cracks and detachment. Despite efforts to make temporary fixes, such as reinforcing the panels, the problem continued to worsen. In the early 1990s, after several failed attempts at patching the marble, a decision was made to completely refinish the building's exterior. The original Carrara marble was replaced with more durable Mount Airy granite, a material better suited to withstand Chicago's harsh weather conditions. The costly project, which amounted to $80 million, was more than half the original price of the building itself. The Aon Center's marble crisis highlights the importance of selecting the right materials for a building's environment. While Carrara marble is prized for its aesthetic qualities, it was not suitable for the challenges posed by Chicago's climate. The building's refacing serves as a reminder that structural integrity should always take precedence over appearances in architectural design. This crisis ultimately resulted in significant changes to construction practices, demonstrating the critical need for careful consideration of materials when constructing buildings in extreme environments. Sydney Opera House. The Sydney Opera House, one of the most iconic structures in the world, had a long and troubled journey to completion. Initially planned to take 4 years and cost $7 million Australian dollars, the project dragged on for 14 years and ended up costing over $100 million Australian dollars. almost 1,300% more than originally planned. Designed by Danish architect Jørn Utzon, the Opera House featured an innovative design, particularly its unique S-shaped concrete shells. These shells posed significant engineering challenges, requiring frequent redesigns and pushing the limits of technology at the time. Utzon's resignation in 1966, due to political disputes and internal conflicts, further delayed the project, adding to the difficulties. The interior design, particularly the acoustics, was left unfinished, and the building was infamous for its poor sound quality when it opened in 1973. This problem led to a major renovation in recent years, costing nearly 300 million Australian dollars to install new acoustic panels and improve the building's sound quality. Despite the tumultuous process, the Sydney Opera House remains a UNESCO World Heritage Site, symbolizing both the challenges and triumphs of modern architecture. The shocking collapse of the Seongsu Bridge. The collapse of the Seongsu Bridge in Seoul, South Korea, on October 21, 1994, remains one of the most tragic reminders of the dangers associated with rapid urban development and neglected infrastructure. At the time of the disaster, the bridge, which had been constructed in 1979, was a critical part of the city's transportation network. Originally designed to accommodate 880,000 vehicles daily, by the early 1990s, it was carrying over 160,000 vehicles per day, more than double its intended capacity. This overwhelming increase in traffic put immense strain on the structure, which was not designed to handle such a volume. On the fateful day of the collapse, a 48-meter section of the Seongsu Bridge gave way during rush hour. Vehicles, including a bus, plunged into the Han River below, resulting in the deaths of 32 people and injuring 17 others. The collapse occurred despite several warnings just hours before the disaster. Reports had surfaced about visible cracks in the bridge, but no immediate action was taken to address these issues. Investigations into the cause of the collapse revealed a combination of factors, including faulty construction, poor welding of critical components, rusted pins, and a lack of regular maintenance. These structural weaknesses had been gradually building over time, and the added strain of increased traffic made the collapse inevitable. The disaster underscored the dangers of cutting corners in construction and failing to prioritize the long-term safety of infrastructure projects. The Seongsu Bridge collapse was a wake-up call for South Korea, prompting significant reforms in the country's construction regulations. In the aftermath of the disaster, the government implemented stricter standards for infrastructure projects and instituted more frequent inspections and maintenance schedules. These changes aim to prevent similar tragedies in the future, highlighting the critical need for careful planning, regular upkeep, and safety in urban development. The Rana Plaza Disaster. The Rana Plaza Disaster, which occurred on April 24, 2013 in Bangladesh, remains one of the deadliest industrial accidents in history. The 8-story building, located near the capital city of Dhaka, housed 5 garment factories producing clothing for well-known Western brands. The building, originally designed for commercial use with shops and offices, was never intended to support the heavy machinery required for garment production. Despite this, factory owners converted the structure to house factories, adding 4 illegal floors without the necessary permits or structural considerations. Just one day before the collapse, on April 23rd, cracks were observed in the building's walls. However, under immense pressure to meet production deadlines, the factory owners ignored these signs of structural failure and ordered workers to return the next day. This reckless decision set the stage for the catastrophic collapse. At 8:57 a.m. on April 24, 2013, the building gave way. Weakened by substandard construction materials and built on unstable land, the structure crumbled to the ground. In the aftermath, 1,134 people lost their lives, and more than 2,500 were injured, with the majority of the victims being garment workers, many of whom were trapped inside when the building collapsed. The sheer scale of the tragedy shocked the world and brought attention to the dangerous working conditions faced by millions of garment workers, particularly in countries like Bangladesh, where safety regulations were often lacking. Investigations revealed that the building's structural integrity had been compromised from the start. It was built on land that was not stable enough to support the weight of the added floors, and substandard materials were used throughout its construction. These factors, combined with illegal modifications, led to the building's fatal collapse. In response to the disaster, the Rana Plaza collapse led to significant shifts in workplace safety standards. In 2013, the Bangladesh Accord on Fire and Building Safety was created, a legally binding agreement aimed at improving working conditions and ensuring safety in garment factories across Bangladesh. The agreement brought together brands, trade unions, and NGOs, focusing on safety inspections, fire protection, and structural improvements. Though the tragedy was devastating, it prompted crucial reforms to protect workers' lives and prevent future disasters in the global garment industry. Champlain Towers South. The collapse of Champlain Towers South in Surfside, Florida, on June 24, 2021, was a tragedy that shocked the nation and devastated the community. The 12-story condominium, completed in 1981, was once a desirable place to live, known for its oceanfront views and prime location. The building was constructed with steel-reinforced concrete, which was expected to ensure its long-term stability. However, beneath the surface, hidden structural issues had been deteriorating the building's integrity for years. Reports as early as 2018 raised concerns about significant issues with the building's structure, including water intrusion from the pool deck that led to corrosion of the steel reinforcements beneath the concrete. This corrosion weakened the building's structural elements, making it more vulnerable to failure. Additionally, the building was constructed on reclaimed wetland, an unstable foundation that contributed to subsidence or gradual sinking of the structure over time. Despite these warning signs, necessary repairs were not made promptly, and the building continued to deteriorate. At 1:22 a.m. on June 24, 2021, the unthinkable happened. In less than 12 seconds, the building collapsed in a catastrophic failure. The collapse left 98 people dead and many more injured, with scores of residents and families affected by the tragedy. The rapid and complete collapse of the building highlighted the critical importance of timely maintenance and inspections for aging structures. The Champlain Towers South disaster became one of the deadliest building collapses in U.S. history and brought urgent attention to the issues of structural safety and building code enforcement. The tragedy led to a national reckoning on the need for stricter regulations and more frequent inspections of older buildings, especially those in coastal and flood-prone areas. In the aftermath, calls for better monitoring of building conditions and faster responses to maintenance needs have grown, as communities and authorities work to ensure such a disaster does not happen again. As we wrap up today's journey through the biggest construction mistakes, it's shocking to see the impact these errors have had on our built environment. If these lessons resonated with you, don't forget to like, subscribe, and share your thoughts in the comments below.